This is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, we will see problem on energy principles, Castigliano theorem. So our topic will be problems on energy principle, or you can say the energy method, and that Castigliano's theorem. So this is the question. That question comes under what? Beam deflection due to various load by the method of complementary energy, or that Castigliano's theorem. So right, with this method we have to find. So just here the question: calculate the vertical displacement of the quarter and mid-span point B and C. So quarter is here, just see that L by 4, right? At this point we have to find, right? And at point C, okay, of the simply supported beam of length L and flexural rigidity EI loaded as shown in figure. So let's see here, this is not the force right now. This is PCF, means what? The Fixious force. But we assume that wherever we have to find the deflection, there we have to put the Fixious load. So only right now this load, this UDL is acting on that one, right? And these two simply supports are there. But where we have to find at this point, that is at B and at C. So B and C, there is no load. There is no direct load because UDL is there. So for finding deflection, what we will do? We will add Fixious force. That's why at point B, PBF is the Fixious force at point B. Similarly, PCF is the Fixious force at point C. Just it's a notation. P at point C, so PC. And PF stands for the Fixious force. And that UDL is given as what? W per unit length is given. So where we have to find this total length is L, and this at B is at L by 4 and point C is at L by 2 from the side A. So we have to find what? Deflection at B and deflection at C. This here. So this figure is beam deflection due to various load by the method of complementary energy method. So first what we will do? First we will find the what? Reaction of this one, that RA and RD. So what will be the reaction? So let's see here. So first, how much force is totally acting? So first force is PBF plus PCF, right, plus W. This, right? These three forces acting downward and these two acting upward. So either you can take downward acting forces as positive, then upward as negative, and that for the equilibrium that must be equals to 0. So I'm writing this upward force as negative. So this is what? RA minus RD. That should be for equilibrium what? It must be equals to 0, then only this system will be in equilibrium. Okay. So now let's take these two to that side. So RBF, so PCF plus W equals to RA plus RB. So this is our first equation. Okay. Now for two unknowns are there. What? This one, RA and RD. So means two equations required. So second equation what? Take moment about any point. Either you can take along about A or about D also. So you can take moment about any point. So just here. First I'm taking here space. So I'm taking moment about A. So moment about A. Right. So A means A at this point only we are considering. So point A means there is no load. So RA, what is moment? Force into perpendicular distance. What is force here? RA. And distance is 0. So RA into 0. Okay. So this moment downward. So just take this as, because of this, PBF into what? L by 4. Okay. Plus for this one, PCF into L by 2, force into perpendicular distance. So from here to here. And this is these two downward, and where this will act? Plus WL into L by 2. For this one, WL is the total length and L by 2 where it will act. So WL by 2. And this upward, so RD into L. Right. So first just see RA into 0 is over. So now from here we can find RD. That must be equals to what? This is. That equals to 0. So from here what we will get? RDL RD into L, right? That is equals to, taking this negative to this side becomes positive, equals to PBF into L by 4 plus PCF into L by 2 plus WL square by 2. Okay, now we have to find RD. So let's divide by L throughout, or you can say just divide this L here. Okay, so I'm just removing this one because this equation we need. So I'm just removing this. Okay, so now here by dividing this side, so this will be RD equals to PBF into L by 4. So L will get cancelled. So PBF by, sorry, so PBF by 4. Similarly here this becomes PCF by 2. Just will LL get cancelled and this becomes WL by 2 plus WL by 2. So now we got the RD. Put here, right? RD, sorry, RD. This is RD, not RD, because here is the support, right? So now RD we got. Put here, we will get RA. So after putting RA, what we will get here? So this RD value we are putting in this equation to find RA. So RBF plus, sorry, PBF. This is PBF. PBF plus PCF. PBF plus PCF, because this load is there. PBF plus PCF plus W equals to what? RA and plus this value. So this is PBF by L plus PCF by, PBF by 4 plus PCF by 2 plus WL by 2. Bring all this to this side. Right, now this is not required. So, because we have to find RA. So, keeping RA this side, RA equals to this, all taking this full thing to this side. So, first what we have, that PBF plus PCF plus W equals to what? This PBF by 4 plus PCF by 2 and, sorry, this all will be minus because that side it will go. So, minus PCF by 2 and minus WL by 2. Right? Sorry, this weight is total WL. So, now PBF minus PBF by 4. So, 3 PBF by 4. Right? This is here. And plus what? PCF minus PCF by 2. So, PCF by 2. Right? WL minus WL by 2. So, WL by 2. So, this is RA. So, now we found reaction of RA and RB. Right? So, RD was this one. Okay? So, now this simply we can write RA as how much? 3 PBF by 4 plus PCF by 2 and minus WL by 2. This is. Now, what is RD? RD is PBF by 4 plus PCF by 2 plus WL by 2. So, now we have both the reactions, right? So, wherever the problem will be there for the where load is acting, first we will find the reaction support. In the later problem we can see first we have to find the reaction of the support and then in each member how much load is acting. So, now we have what? The reaction forces. Okay. So, now just see what we will do. We will apply the complementary energy equation. So, the total complementary energy C of the system including the fixed load PBF and PCF is. So, by including, so just see here, this is the load and because of PBF, what will be the deflection? Delta V, that already we had seen at this point, whatever the point, like P2 was there, so P2 delta 2. So, here PBF at point B, so delta B at the deflection. Similarly, PCF minus delta C, these two are downward, so negative. And this from where to where this delta L is there, the W is working from 0 to L. The total weight is from here 0 to this total length L, right? So, del W into del Z, where dz will vary from 0 to L, right? And this whole, this d theta into dm, that will be the moment around this one, where dm will vary from 0 to m, how much the moment will be there, right? So according to the complementary energy equation, this will be the equation of C. Now here what we have to do, first we have to find the value of which one? Okay, or let's see first for finding. So this is the general complementary equation for all point B and point C. Now what we will do, what we have, just recall the concept. Wherever we have to find, differentiate whatever the load, Fixed load we applied. So let's find for B. This what happened for finding this delta B, PBF is there. So means this equation we have to differentiate with PBF. For finding C, that means deflection at C, we have to differentiate. Here PCF is there. So this whole equation to PCF. Okay, then only PBF and PCF will get removed. And because we applied that fixed load, so in that we have to remove that one. So let's start with differentiating this equation to PBF. Okay. So now after differentiating, what happened? C becomes delta C by del PBF. This becomes, so because of the integration and differentiation, this will get cancelled. D theta into dm by dPBF minus PBF, differentiation of PBF becomes 1, like differentiation of x, because with respect to x only we are differentiating. So differentiation of with respect to x is 1. So similarly here we are differentiating with respect to PBF. So PBF becomes 1 and delta B. PCF is what? Constant. Differentiation of constant is 0. What is here? This delta W into delta Z. That also because here dz is there and W is there. Both are independent of PBF. Means this term also is constant, since 0. So after putting del C by del PBF equals to integral of L. This stands for the overall L or entire span, or you can simply, the same meaning is 0 to L also. So the see here, if you will put lower limit, then you have to put upper limit also. Then lower limit will be this one, upper limit. If you are just simply putting here and you are not keeping here, means this is the integration of the entire L. Okay, so here this is. Now if we will differentiate with respect to CF, then what happens? So del C by del PCF into similarly d theta, that this again this will get cancelled. So integral of L d theta by dm by here del PCF. Now this time PBF is constant because we are differentiating with respect to CF, that PCF. So this time PBF will be 0, sorry, constant. So differentiation of constant will be 0. Similarly, PCF is variable here this time. So PCF differentiation is 1. And again, this will be constant. So this again, this will be 0. Right. So after differentiating, we got this as del C by del PCF equals to integral of L d theta into dou m by dou PCF minus del C equals to 0. Now why this 0? Because of the for complementary energy equation that already we derived for the equilibrium, that must be equals to 0, then only that will be in equilibrium. So after putting 0 from here, what we can say, B delta B equals to this one, right? Take this side. So delta B equals to this one. Similarly, delta C equals to this one, right? So that is here. So now assuming a linearly elastic beam, equation 2 and 3. So this equation and this equation becomes delta B equals to 1 by EI m into del m by del PBF into del Z. So what we did here, from the bending moment equation that already we had seen in mechanics of solid, that d theta is what? M by EI into, so d theta by dz, or just moment equation. So that will be del m into del z by EI. So just replace d theta with this m by EI into dz. Right. So what is here? 1 by EI is constant. So out of integration. Now what is left here? 0 to L m dou m by dou PBF into dz. Right. So this is for delta B in terms of moment. Now this d theta is not required. That's why we remove this d theta. Okay. So now this is for delta B. Similarly for delta C, again just replace delta m. So m dz by EI. Now this becomes C. Now see the equation what we have. In this equation you can see m and delta m is there, right? So now first we have to find m value and then we can substitute in this equation to get the delta B, and here we will put in this equation to get the value of delta C. Right? So now moment we have to find for each point. Like from where to where? From A to B, from B to C, and from C to D. Right? So let's find first moment from A to B. So see here, this force we got right here. That moment at A to B is because of what? Okay, so now just imagine any distance that we can put it at the suppose somewhere here we are finding, right? So moment at just here, at A we got and at D we found from there. Okay, so just here moment from A to B, this is the reaction force into Z will be the moment, right? So this is moment at any section Z. Suppose here from here to here this distance is Z. That Z can vary from 0 to L. That will while integration that we will see. So that already just here 0 to L we have taken. So in terms of dz only we have to find. So this is the moment, that reaction force we found into Z, and minus this is what? Because of the weight. So Wz into Z by 2. So Wz is the weight and Z by 2 is the length. So weight our force into perpendicular distance is the moment. So this is moment about A. Now M we got. So we can substitute. Now here one more thing is what? Here del M by del PCF is required. So let's differentiate this equation. So after differentiating this equation, what we will get? Here this is constant, right? Because PBF is there. So PBF becomes 0. Now differentiation of this becomes what? This one. For with differentiating with respect to PBF. Sorry. Anything you can differentiate. Or just let me here expand first this one. So now I am just multiplying inside this one. So M equals to 3 by 4 PBF into this Z. Right? Plus 1 by 2 PCF into Z plus WL by 2 into Z minus WZ square by 2. So this is the after expanding. Now what? Let's differentiate one by one PBF and PCF. So del M, because for this equation del PCF is required. For finding delta B, PBF is required. So first I am differentiating with PBF. So del M by del PBF equals to, so PBF is here this time variable. So this PBF becomes 1. So this will be give 3 by 4 Z plus 1 by 2 PCF. PCF is constant. So differentiation of constant is 0. Right? So this whole thing becomes 0. Now WL by 2. Here again PBF is not there. So this also is constant. So 0. Here also PBF is not there. So this is also 0. So what is left? Only 3 by 4 Z. Now the same equation differentiating with respect to what? PCF. So delta M by del PCF equals to. So now here this time PCF is not there with this term. So this term becomes constant. So PBF is constant. Hence differentiation of constant is 0. Half PCF Z. So half PCF. Now this time PCF differentiation becomes 1 because with respect to PCF we are differentiating. So half Z. Plus again here PCF is not there. So 0. In this case PCF is not there. So WZ square by 2 differentiation also. That is constant. So it's 0. So 0. So now what we got? Delta M by del PBF as 3 by 4 Z. Delta M by del PCF as 1 by 2. So now we have this value also, this value also. So put this value here. Okay. And this is PCF. So this value for this one. Similarly, put this value for M in delta V equation and del M by del PBF, that is 1 by 2, sorry, 3 by 4, get in that equation. So then you will get delta C, that deflection because of the A and A to B only. Right. So similarly, we have to find what? From B to C also, C to D also. And then the overall we will add and substitute there. So now for B to C. So now just see B to C, this reaction will be there. Right. Then how much load in between B to C is acting? That WZ square by 2. So this will be same. Now what will be there? So let's see the figure. So if this distance we have measured that as Z, and this is what? L by 4. So this distance will be what? Z minus L by 4, right? So that is here. So PVF into Z minus L by 4 moment, right? And these two will be just like previous one up to AB. So now this term will get added. Okay, so this is for PVF and PCF. Like this is a moment equation. So again, for moment we have to replace this one for B to C. Okay, now what happened? Again the similar way, just differentiate with respect to PVF, substituting delta B, differentiate with respect to PCF, substituting delta C. So after differentiating this with respect to PVF, so this will becomes delta M by PVF. This becomes 3 by 4 similarly by multiplying with this Z, right? So 3 by 4 PVF becomes 1, so 3 by 4 Z, right, from here. And then half PCF, PCF is constant, so 0, WL by 2 is also constant, so 0. Now here WZ square by 2 is constant, 0, but here PVF is there, so PVF Z, right, that is here. So PVF and Z, this L by 4 will be there also, right? So Z minus L by 4. Now what we have here, 3 by 4 Z minus 3 by 4 Z minus Z of L by 4, or just let me expand this one and it will be more clear. So first multiplying with this Z, okay, and then this also I will multiply. So 3 by 4 PVF Z plus 1 by 2 PCF Z plus WLZ by 2 minus WZ square by 2 minus I am multiplying, so PBF Z plus PBF L by 4. Okay, now differentiating with respect to PVF. So PVF is here, just see whatever the term is there, that only will be there, remaining all are constant. So PVF is here, PVF is here, PVF is here, right? So now this term will be 0. So no need to differentiate. Now here after differentiation what you will get? 3 by 4 Z. Here after differentiation minus Z, and after this it's a plus L by 4 because this PVF becomes 1. So now 3 by 4 Z minus Z plus L by 4, that will give you what? Z minus Z by 4 plus L by 4. Take 1 by 4 common. So this will becomes L minus Z. I am keeping just this first. So here 1 by 4 L minus Z. Right? This is for what? PVF. When we differentiated with respect to PVF. Now when we will differentiate with respect to what? Now the next time is differentiate with respect to PCF. So just here PCF where is there? Only with this term. Right? PCF is only here. So this will be 0. This term also will be 0. This term 0. This time this also will be 0 because PVF is there. So this term also is 0. So now what is left? Half PCF into this Z. So half PCF into Z. Now differentiate del M by del PCF Z will give you what? Only 1 by 2 into Z. So half Z. Yeah. Del M by del PCF is half Z. Okay. Now from C to D. Again this equation, now this time from left to right I am coming because C to D. So reaction into what will be the length? Let's see here the figure, because up to now from this side we are going, right? So this distance is Z. So from here to here what is that? L minus Z. So this reaction into L minus Z, that will be the moment. So just see here, this reaction into L minus Z will be the moment. Now W by 2, that is this one. For how much weight it will be? So just see here. Now for this length only we have to take. So what will be the weight? Because up to this already we considered. So from here to here, so this length is L minus Z. So for L minus Z only we have to take weight. So weight will be W into L minus Z. Now moment will be what? Where it's acting. So half of that one. So this total weight will act somewhere here. Half of this L minus Z distance. So this L minus Z by 2. So this we can write W into L minus Z whole square by this 2 here. Right? So this is the moment from this because of this load. Okay. So W by 2 into L minus Z whole square. So now this is the moment equation, right? So now once we have the moment equation, similarly what? Just differentiate with respect to PBF and PCF. So first differentiate with respect to PBF. So where is the PBF? PBF is only with this term, right? So this will be constant 0. This will be constant 0. This also, there is no PBF, so 0. So now what is that? 1 by 4 PBF into this L minus Z, right? So now differentiate, so this PBF becomes 1. So what we will get after differentiation? L minus Z by 4. So 1 by 4 L minus Z, that is dou M by dou PBF. Okay, now for PCF. So where is the PCF here? So this time PCF is not there, so this will be 0. Here PCF is not there, so this will be 0. Here PCF is not there, so this also will be 0. What is here? So 1 by 2 PCF into L minus Z, right? So now after differentiating, this becomes 1. So what we will get? Half L minus Z. So del M by del PCF equals to half L minus Z. Okay, so now we got the value of all the moment and moment in that del M by del PBF and del M by del PCF for that portion. Okay, so now substituting these value in equation 4 and 5, where we have to substitute 4 and 5. Yeah, 4, that is this one delta V equation, and delta C equation, just these values. So M, add total, M will be the total M, and similarly this delta M, sum of all this one. So yeah, after 4, this is for delta B. So see here, after substituting first in 4, so 1 by EI, right? This is what we got, the value of which one? Let's see here, M, so A to B, M, and this 3 by 4 Z. So this whole thing is the M, and del M by PVF, because first we are finding PVF, so this we will not consider this time, this and this only. So here, then from this is from 0 to L by 4, first part, right? This is for L by 4 to L by 2, that is, this is for what? A to B, this is for B to C, and this part is for L by 2 to L, that is C to D. Just substitute all the part, you will get this one. Now what you have to do here, you have to integrate this one. So how you will integrate? First expand this one and then just differentiate. So I am just showing for 1. Similarly you can do for the delta C. So just see here, first this 1 by E is constant, so I am just keeping out that one, right? So first let integrate part 1 by 1. So here what we have, 0 to L by 4, right? I am multiplying this term inside, so this becomes 3 by 4 into 2, so 3 by 8, then W L Z square into dz, after multiplying this with this term. Then this is inside the integration, minus W, so 3 by 4 into 2, so 3 by 8 W Z Q dz, right? W Z square into Z Q dz, right? This we have to integrate 0 to L by 4. So just see here, 3 by 8 WL is constant, right? So 3 by 8 WL is constant, integral of 0 to L by 4 for Z square dz, minus similarly 3 by 8 W is common, here ZQ dz, integral of 0 to L by 4, right? So now here we have to integrate, so what we will get? 3 by 8 WL as it is, 3 by 8 WL. Integration of Z square is what? Z square dz is ZQ by 3. So ZQ by 3, limit from here to here, 0 to L. Okay. So 0 to L by 4. This is for L by 4. So yeah, 0 to L by 4. Now this over. Then minus 3 by 8 W ZQ differentiation, so the integration is Z power 4 by 4, limit 0 to L by 4. Okay. So now once we will put that one, so the see here, this will be 0, so upper limit only we have to put. So 3 by 8 W L into this L by 4. So L by 4 whole cube by 3 minus 3 by 8 W L by 4 power 4 by 4 after putting the limit. And 0 if you will put for this also minus 0, minus and minus plus 0. So that is not. Now this we have to simplify. Okay. So this will give you what? 3 by 8 WL. Okay. This becomes LQ by 64 into 3. So LQ by 64 into 3. Or this you can just multiply. So this will be 212 minus 3 by 8. Sorry. 192. This will be. Right. 3 by 8 W, and this will be what? L by 4. So L power 4 by 256 into 4. Right. Just multiply. Just see here, this WL is there. So L you can keep, and then you can just take remaining things common. So once you will put here everything where it will be L in terms of L. So just simplify, just see L and LQ. So power L by 4 and power L by 4 also is there. So you can simplify. So just simplify this one. You will get this value. Similarly, you can do for this also. Just see here how you will check that your answer is coming near to that or not. Here L by 4 we are getting. So just see here L cube into L by 4. Here already L by 4 is there. Right? So power L power is correct. W is already one with one power. So W is there. Now only the thing, these values you have to multiply, subtract for all the parts. Okay. So now this you have to just simplify to get this one. Now I am showing again integral of this only, remaining addition subtraction you have to do. Okay. So just see here. Now for B2C. So for B2C what we will do? First again same, just here. So this part 4 L by 4 minus Z by 4. We will multiply here. Okay. So first, so just see here, this time 2 terms is there. And 2 here. So total 4 terms will be there. So this will be L by 4 to L by 2. First I am multiplying with this 1 by 4L. So WL by 2 into 1 by 4L. So this will give you what? WL square Z by 8. 1 by 4 multiplying. Then 1 by 4 multiplied to this one with this WL Z square by 8. Right? This multiply. Now 1 by 4Z we have to multiply minus 1 by 4Z. So this becomes minus WL minus is there. So after multiplying minus WL Z square by 8, and this minus becomes plus. So plus WZQ by 8. This whole thing we have to integrate, and then we have to put limit from where to where? L by 4 to L by 2. So upper limit is L by 2 and lower limit is L by 4. Right? Just integrate, and everywhere see here just dz will be there with each term. Without dz you cannot integrate, so make sure to put this one. Right? So now here, so WL square by 8 is constant, so here z is there, right? So z dz integral is z square by 2, right? And this is WL square by 8, and this is L by 4 and L by 2. Okay, minus WL by 8 is constant, so minus WL by 8. Now what is here? Z square becomes ZQ by 3 power lower limit L by 4 to L by 2 minus for this term WZL square WLZ square, right? So now this becomes what? WL by 8 ZQ by 3, right? Then L by 4 to L by. So just see here, or you can see these two terms are same, WLZ square 8 dz. So this directly we can cancel instead of doing that one, right? So these two terms are not required. What is left here? This term. So I am just editing this term because these two terms are same. So I will integrate. Now integration of this will be W. Okay. Z cube. Okay. So Z cube becomes Z power 4 by 4, and here ZW Z by 8. So this is L by 4 and L by 2. Now let's see here. So this is L by 4 to L by 2. Now once we will put the LCM here, so this will be what? This L by 4 over. So now WL square by 8 into first upper limit. So L by 2 whole square, right, by 2 minus L by 4 whole square by 2. This term over. Okay. Minus W by 8. Similarly L by 4 to L by 2. So L by 4 power, sorry, L by 2 power 4 by 4 minus L by 2 power 4 by 4. Right. Now see here. First with this term, L square is there and here L square by 4 by 2. So L square becomes, right. Here also this you can see the L square is there. So once we multiply with this L square, this becomes L power 4, this becomes L power 4. Now here, so just minus W by 8, right. This L by 4, sorry, L by 2 power 4 means L power 4 by 16 into 4. Minus similarly here L by 4 and by 4. Okay. So L by 2 power 4. So L power 4 by 16 divided by 4. Right. So this we can find. Okay. So this is 64. So L by 4 just here with all the term we are getting. So once you will simplify this one, only one term in terms of L power 4 will be there and with some constant, some numerical value. Right. That also you have to add with this we found. Right. Next, the third one is, okay, third one we have to integrate this one. So let's see. So again, first we have to multiply this 2 term here. So just first multiplying, keeping that L by 2 to L. Okay, now just see here. Both are same in this case. But the thing only, so all the integration will be same only at the time of putting the limit that you can put L by 2 to L. Just see here, WLZ by 2 minus WZ square by 2 into 1 by 4 L minus ZZ. So same is there. Either you can do. But here what we can see, this is for what? From B to C. And this is from C to D. But both are coming same. So directly we can also take from where? Directly L by 4 to L. But what we did, we found separately for A to B, B to C and C to D. So that's why we added all the 3 terms. After just see here, once you will get that one, to save the time, what you can do, directly this term and plus this term, both are same. So you can write inside here, this term and this term is same. So directly we can take the limit from where to where, this L by 4 to L. So you need to integrate only once. But first you have to show this term that you found for all the 3, that is A to B, B to C and C to D. And after, it's not necessary that you will get the same. That depends on the given numerical value. But if you are getting same, then you can integrate from the starting limit to the ending limit. So starting limit is what? That L by 4 and ending limit is L. So directly this equation you can integrate from L by 4 to L. Right? After integration, just substitute the value. Right? Simplify it. Then add all the 3. Because don't go with one equation and expand and integrate everything. Just take this as I1, I2 and this as I3. And later you can write I2 equals to I3 or integral of L by 4. Like that you can just put and then you can integrate. So now I will be equals to what? I1 plus I2 plus I3. Or you can just integrate this one, keep there and put power, in this case L by 2 to L. That also you can do. Okay. And then just simplify. After simplifying, you can verify. Okay. In class also we have checked. After simplifying, you can see, you will get delta V deflection as 119 WL power 4 by 24576 EI. This is approximate value you will get. Around this value you will get by simplifying. Once you will simplify and add with the calculator, you will add, then you will get this value. Make sure here don't take in decimal parts, or if you are taking decimal part, then this divide 119 by 24576. Okay, then you can see, then here whatever the decimal value you will get, that will be same. So if you are taking in the fractional one, then keep all the three in the fractions only, and if that is coming in decimal or you are taking in decimal, then all the decimal, and then check this value in decimal. So this is not required that you have to keep in this only that numerical value. You can keep in decimal also. Okay, so this is for delta B. Now for delta C. So similarly, just what we have to do here, these values you have to put where in delta C equation. Where? Here. M will be same, delta M will be same, just whatever you differentiated with respect to PCF, that will change. So this del M by del PCF will be different, M will be same. So here in this case what we got, del M by del PCF is 1 by Z. For A to B, this remains same. For B to C, what we got here, del M by del PCF is 1 by Z, and for which one, that C to D, del M by del PCF is 1 by 2 L minus Z. So now just see here we are not getting, in previous we got both 1 by 2 L minus Z, here 1 by 2 L minus Z, but this time we are getting different with respect to C. So same moment you have to put here, same moment, only that distance you need to change, that this value, right, that del M by del PBF is there. So instead of del M by del PBF, now here you have to substitute del M by del PCF value. Okay, and in the same way you can just expand, integrate and solve, then you will get just only one thing you have to remember, that what, for finding del C, here you have to take del M by del PCF. Del M by del PCF for, this is for A to B, this is for B to C, and this is for C to D. That after putting and simplifying, you can see you will get that delta C equals to 5 by 384 into WL power 4 by EI. So see here, in this delta C also is WL power 4, right? So here see the comparison, 5 by 384 EI. So EI will be constant because the same material is there, right? And into WL power 4. So I'm just writing here this WL power 4 by EI here. Right, by EI. So this is for what? Delta C. Now, what is delta B? That you can see just here, 119 by 24576. So 119 by 24576 into WL power 4 by EI. Just see here, WL power 4 by EI, right? So now just see here, this is same for both the cases. Now here what we have, 5 by 384, and here this is 24576, 24576. Now let's see which one will be greater, delta C or delta B. Once we will divide with this bigger number to this one, definitely this value will be the smaller one, right? So we can say that at delta B, less deflection will be there compared to delta C. So at delta C, the more deflection will be there, and at delta B, less deflection will be there. So like this we can find. So instead of that, if suppose they will give the numerical value here, right, like they will give 10 per unit length, and this length is 200 mm, so this total is 1000, so this will be 250, this will be 500. So directly you can put there, but for numerical value you can use this. If you remember this formula, then you can use it, or else you have to derive, then substitute the value. Or if suppose they will give directly this one, right, without any numerical value, then just go with the same method and find the value. So just quick recall once again. So first what you have to do, so the question is what? A simply supported beam is there in that UDL is loaded. Now at L by 4 from A and L by 2 from the side support A, need to find the deflection. So assume that point as B and C. So at B and C we have to find the deflection. So according to the principle of conservation of energy, what we have to do, if load is there then it's okay. If load is not there at that point, then we have to apply a point load. That is from earlier we had seen in the Castigliano theorem also, that complementary energy method. So just applied PBF at B, because B is there, so just for denotation So it will be easy to identify. And PCF force at that fixed force at C, and PBF is fixed force at B. Now, so these two forces we assumed, this force is given. Now what we have to do? We have to find first these supports. So just apply the sum of vertical forces and horizontal, that upward and downward forces, means one equation for force, another equation for moment. So that find RA and RD. Once you will have RA, RD, then now next we have to use the complementary energy method. So this is the complementary energy method, right? Here what we have to do? We have to find with respect to PBF, that is at del B and del C, right? So for finding del B, what we have to do? We have to differentiate with respect to BF. For finding deflection at C, we have to differentiate with respect to CF. So just differentiate this equation with PBF, you will get this one. Differentiate with respect to CF, you will get this one. Okay. Now here we can see that d theta is there. So d theta from the bending moment equation that we can, or bending equation that we can replace, that is what? Del m into m into dz by ei. So here just replace this theta. So m dz by ei, that gives del m by into del m by del pf. Now here what we have to do? We have to find the moment. So this will be what? This is for delta B. Similarly from delta C here, this will be what? M into del m by del PCF into dz and 1 by ei outside, that is equals to delta C from the equilibrium condition, right? So this is the delta C. Now what we have to do? We have to find force, that moment in terms of the whatever the load is acting. So first we have to find the load. How we will find? Separately we can find the load, because at different points the load is acting at L by 4, then L by 2, right? So first at A to B means at length from 0 to L by 4. So this is the reaction that we found, right? Into Z will be the moment. Z is what? Here we assume somewhere here that we are taking that section. So from here to here, this is L by 4. So this will be L by 4 minus, this part will be L by 4 minus Z. Okay, so this one, A to B, this and Z, and into, for up to that Z, WZ square by 2. Right? Now, just differentiate this with respect to, because this also we require del m by del PCF. So differentiate this equation with respect to once PBF and then again with PCF. So after differentiating with respect to PBF, we got this one. Differentiating this equation with respect to PCF, this will be there. So now for this we have m value also, and PCF and del m by del PCF and del m by del PCB we have. Substitute here. Not now. Next. Because this is for A to B only. Now next what we have to do? We have to find B to C also. So same B to C. Right. This will be the reaction support into Z. That what we got from the first A to B, and then just in between B to C, PBF into Z minus L by 4. So just here. This is, because this is from here to here is Z and this is L by 4. So this distance is Z minus L by 4. So PBF into this distance. Z minus L by 4. Now next, what we have to do? Again same thing. Differentiate with respect to PBF and PCF. Then you will get what? Del m by del PBF equals to 1 by, or del m by del PBF and del m by del PCF, this one. Now similarly from C to D. So C to D, just see here. C to D we can go by this method also, because this support we know, right? So we used this one. So to support at that one, what will be the distance? This is Z up to this from this side. So this distance will be L minus Z. So that is used. Yeah, L minus Z. And for that L minus Z weight, W by 2 into L minus Z will, W into L minus Z will be the weight, and L minus Z by 2 will be the distance. So this will be there. Now again differentiate this one with respect to PBF, with respect to PCF, we got this one. Now all we got M for all the 3K, that A to B, B to C and C to D, and del M by del PBF and del M by del PCF for all the that section, that A to B, B to C, and C to D. Now just substitute where here for del B in this one with respect differentiated with respect to PB and differentiated with respect to PC in this one, and just simplify here. So after substituting, this is for delta B. So after substituting here for delta B, you will get this one. I showed you the integration also. So just integrate separately because limit is different. Integrate separately by considering I1, I2, I3, right? Put the limit and then sum of all will give you the value of delta B, which you will get delta B equals to this one. Similarly, moment will be same. Just in the next delta C equation, this you have to just put delta M by del PCF here, right? This will be same for all the cases. Just substitute, integrate. Don't just repeat that same thing. Integration won't be same because this will be same, but this value is getting changed, right? So integration won't be same. Don't go for the same integration. This because of this value you have to multiply, then expand, integrate, substitute the limit, then you can see the delta C value will be this one. Okay, so this is here. Like that you can just simplify. So this is your reference, that THG Mexen book. So if you have any doubt regarding this question, you can just comment on the video or you can just contact me. I will clarify your doubts. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.